Hello, greetings, programmers. Welcome to Upgrading and Maintaining Delphi Legacy Projects. Joining me today is Bill Meyer. Hey, Bill.
Hello.
Bill is the author of this book, which you can see on the screen, and I've got a copy of here as well, Delphi Legacy Project Strategy and Survival Guide. Honestly, I heard about Bill writing this a while ago and I was really excited about it because he's tackling a lot of things that a lot of people ask questions about and deal with a lot. So I think it's going to be useful, but I have not had as much chance to read it as I would like. So I'm really excited about this today because we're going to talk about the book and talk through it and stuff. With that, I'm going to go. Let's go ahead and I just wanted to say hi to everybody. Let them see us, and then we can turn the webcams off and dive in here to your slides.
All right, sounds good. Okay, so something that I wrote after spending a lot of time fighting my own battles to find my way through problems that I had been encountering and for which I didn't have ready answers. One of the first triggers was an issue with an ever-increasing build time that went in the space of a year and a half or so from a 30-second build to an 8-minute build, which proved to be an effective unit dependency cycles. So after rooting around in what I'm referring to as legacy issues, but might also be, as Jim and I spoke about a few minutes ago, that some people don't like the word legacy, but what legacy means is you have a successful and profitable product. And
yes.
It has a long life, and the longer its life, the more you have to live with, because like it or not, entropy happens.
Actually, you know what? I realized, Bill, I didn't really introduce you beyond just that you wrote this. You're probably a lot in common with myself and probably a lot of people attending as well. Has been programming in Delphi forever, since Turbo Pascal, working on lots of projects. And you worked on a number of different companies as well, right? A lot of different projects.
Yes. My starting point actually was Turbo Pascal 1 on the Z80 under CPM.
Oh, wow. Okay, yeah.
I still have the manual from that. Most of my work has been involved with broadcast television.
Okay.
I did do a couple of years on Delphi product for a small medical office practice management, which was fairly nightmarish, as much because of HIPAA as anything else, but also because it was another legacy project. And when I started working on it, it was in Delphi 6, and by the next year we had moved it to 2006 with a fair amount of pain along the way. And that's another issue that I discussed somewhat in the book, this problem of moving from an old version to a newer version. It'd be nice to say, well, just install all the components and move the code and away you go. But no, the larger the gap between the Delphi you're coming from and the Delphi you're going to, the more adventures you're going to enjoy along the way.
Yeah, I've been involved in a number of migrations to newer versions of Delphi, and there's a lot of things you can do there. And I know you have a lot more in the book than we're going to talk about today in the slides, but let's go ahead and get going through here.
Okay. So as I'm saying here, legacy projects tend to be large and typically module counts over 1,000. Deciding where to start can seem difficult, but the reality is something will probably jump out at you. And if it doesn't, you can start almost anywhere, whatever seems approachable, because sooner or later you're going to have to deal with all of it. All of these different products and projects are going to be different from one another, and yet there are a lot of common threads throughout. And another thing that Jim and I talked about before the start was that to a certain degree, I want to say rad is bad, because everybody's introduction to Delphi was probably seeing a demo where a button was dropped on a form, double click the button and start writing code. And that's a fail point right there, because testing the form requires either human interaction or an expensive scripted product, and it's slow and coverage is difficult and so on. Any control on a form ought to have as little code as possible in that form, and the code should live somewhere else so that it can be tested with ordinary unit testing. Any version could be your starting point. The earliest version I've worked on for a migration was Delphi 6. And any of this and all of it will try your patience, and you're going to have to be determined to reach the endpoint, because there'll be a lot of frustrations along the way and a lot more work than you anticipated on the way in. I don't try to present a lot of code, partly because the code that I've worked on, of course, is proprietary and I can't display that. And sitting down to write bad code is more pain than I want to endure.
So true.
But a starting point that I decided on here is when you have mixed projects, meaning you have a source code tree that contains multiple projects. That's a problem because in making changes for the sake of whichever project you decide to start on will cause breakage in those other projects. And shared modules that are not libraries as such make it increasingly difficult. And even libraries can be problematic unless they're as clean as libraries that ship with Delphi. And when I say clean, I'm not talking about whether there are defects. I'm talking about whether there are unpleasant dependency interactions amongst the units. In particular, a phrase that I'll repeat a lot in this unit dependency cycles, where unit A uses B, which uses A, and that's not good when it's that small, but when that string is 100 or more units, it's really ugly. So my suggestion is you start by creating a new folder tree for your target project. Copy into that tree all of the files you need to build that project and nothing more. And keep it to that one project. Now, what that means along the way is, although it minimizes the problems you'll have directly from your rework, there's the issue of, gee, I fix a defect over here, and that same defect exists in this other project. There's a temptation then that you have to fight, and the way to deal with it is to take the unit you fixed and the diff tool and merge changes from that into the other copy of it in the older tree if you need to make that change before you carry on. If you try to do too much stuff in parallel, then your timeline just gets very bad. And in the long haul, there are solutions to updating those projects. I suggest you start with a root level folder that is going to contain nothing but other folders. And the reason for that is that the IDE sometimes makes interesting choices about how to put the path in the DPR and the dproj. And what you do not want it to do is add the disk identifier into that string. If you elevate your actual folders above a root level folder, generally that saves you from that particular problem, which you otherwise have to fix with a text editor, not with the IDE, because the IDE and you will be fighting one another. So the new source folder is your new focus. Project 1 is your main concern. The libraries folder is secondary and for the moment ought to be empty. The reason for that being that anything you put in the library folder needs to be really clean, at least in the sense that it doesn't create or contain unit dependency cycles in relation to other library modules. And it'll take you a while to reach that point, but it's not worth moving things over there before you have them really clean. And don't think about the changes you're making in project 1 and what that'll do to other projects. The shortest path you're going to find is to do what you need to do for this primary project and reach the point where it builds and makes it through regression testing and can be shipped. Then you can go back, I'll go back now, go back here and add project 2 into this new tree and bring into that whatever you need for the second project and carry on from there. You're still not intermingling projects as was done originally. This does raise issues when you come to the point of forms that are going to be shared or data modules that are going to be shared. And once again, you really need to make them as clean as possible before you put them into that shared folder. And then once you've done that, once you put them over there, you're going to have to keep them clean, but also you're going to have to keep verifying that both of those projects work properly with modified modules. Being in a hurry to put things over there is counterproductive. Library modules need to be rock solid and clean, meaning they shouldn't create issues for other modules. They shouldn't use modules from project 1. Library code should not use anything that's part of an actual product. The product code can use the libraries, but not the other way. And they need to be as usable in isolation as any Delphi library. It's harder to reach that point than you might think at the start. I've seen modules that I've tried to clean up, and short of really factoring things out into separated new modules, I haven't found a strategy that is particularly effective. Sometimes you get lucky. I did in one case where I had a module that was participating in over 800 unit dependency cycles. I found one routine that was clearly something that should have been in a different module. I moved it and all of those 800 unit dependency cycles went away. But most of the time you don't get that lucky. At some point, large projects may begin to suffer long build times. That was the starting point of all of this for me, and they were the result of unit dependency cycles. A UDC is created when Unit A uses Unit B, which in turn uses Unit A. And in a large project with many UDCs, once the build times begin to increase, the problem will multiply. Some analysis over a period of builds that covered about 2 years showed me that there was an exponential increase in build time where the exponent was really small, about 1.03, but 3% compound interest can kill you over time. The UDC effect on builds is an exponential burden because as you add features, you will add modules, and those modules will use other modules that are already involved in UDCs. And so it's a power function of some sort. To reduce the size of the problem didn't appear overnight, and the cure won't either. It's going to take a long-term effort to factor and refactor, and you won't be able to say, okay, I'm going to refactor this file and stop when I'm finished. It's not going to work. You'll find that some of the refactoring you need to do leads to changes being forced into other modules and so on. So there'll be some spiral activity along the way, and you just have to keep working at it and looking for the improvements as they occur. In the isolated tree, the effect of any work you do is limited to that tree. You don't have to worry about breaking other projects. You will need to be incremental in your approach no matter what it is you're touching, and be pragmatic in anything that you do. If you haven't read Refactoring by Martin Fowler, that's probably the single most important text you should read, although really the value's in the first part of the book more than in the last, where he is giving a catalog of examples in Java.
A number of those really, I'm a big fan of those seminal books like that one. And I find that it's the same thing like you just said, is that I start reading it and it's like, at some point my brain gets it and I'm like, oh, I get it. And I don't need to read the rest. But yeah, like that one. And a lot of them have, a lot of the book is like a lot of examples and stuff. But when you get the basics of it, you might look at some of the examples and you're like, okay, I understand now. I can go apply this in Delphi, even though the book itself is talking about Java or whatever.
And another aspect of that is it compares similarly to the patterns book from the Gang of Four. Patterns there, some of them don't transport to Delphi particularly, because Java is not what Delphi is. And so trying to force Delphi into a Java container is a painful exercise and not particularly beneficial. It's better to take what you can from the first roughly third of that book and start looking for the patterns you find in the code that you have to deal with.
I remember the big thing for me with patterns, and I realize we're getting a little off in the weeds here, but was just this idea of recognizing a pattern that shows up again, right? And so, oh, that's what this is. That's what's going on here. And then when you see it later, you can be like, okay, so that's a pattern. So there may be some patterns, like you said, that are specific to Java, and there are other patterns that are specific to Delphi. So it's an interesting idea, and there's some utility in looking at that Gang of Four patterns books. But then the other thing is the concept of patterns, and then start to recognize maybe patterns that are unique to you or unique to your language or unique to your team as well, and figuring out how to improve those patterns and stuff. Anyway.
And again, Miller, as I cite him here, says the big danger is pretending you can follow a predictable process when you can't. But the very next point, I'll credit to Fowler as well, though I didn't go looking for it in the book, that any file you edit, you should leave it better than you found it.
Yes.
Because this project is big and it has decayed over time, and your only path to repair is going to be incremental. So while you're here, if you've been studying some part of the code because of a defect case you're working on or something, maybe you've observed something there that needs some repair. So go for it, or at least document before you leave that there's something here and what the nature of the fix might be, so that when a case is generated and handed off to maybe somebody else, they're not starting from square one.
I know in your book you talk a lot more about some specific tools and examples and stuff. There's a couple people asking for tools here, which we can do some more, talk about that more at the end. I don't know what I was going to say now. Go ahead. Sorry.
Another hugely important point is to keep scope as narrow as possible everywhere. Make everything private until it's forced to be more visible than that. Because the wider your scope is on anything, the greater the potential for cross connections that will introduce defects. And advice that's been good forever: remove global variables where possible. Global types and global constants are not problematic. And in fact, I would make a case for gathering them together into possibly a number of types modules and a number of constants modules named to give you a clue about the areas they address. But the reason for that, for collecting them that way, is that there may be places in your project where reference is made to a unit in order simply to gain awareness of a type or a constant, but has the side effect of dragging in UDCs. Types and constants can't drag in UDCs. Because they're used by the compiler, they do not turn into code. So there's an advantage and no penalty for isolating them in their own space. And then, of course, you need to remove them from the module they were in, and you'll have to fix unit references there and elsewhere where something has been relocated until the thing builds again. And that's another one of these behavior patterns that you're going to have to spend some time getting accustomed to, and again, keep chipping away at it, because you can't just say, okay, I'm going to drag 87 variables over here and fix what breaks. You'll create a huge mess. But you can say, okay, from this particular module today, I am going to try to relocate the public variables or the public types or public constants, with the exception, of course, of form classes, which have to remain where they are. And that's just part of the incremental work that you have to do sooner or later. Testability is a big concern, and typically a legacy project can't be unit tested because you don't have the isolation that's needed to be able to test things independently. Code on forms, I've already talked about, is a big issue. Excess complexity of routines. Routine ought to be small enough anyway that you can see it all on the screen at one time. On focus code that's trying to participate in 8 or 10 different things that all need to happen, but don't necessarily need to happen in that one place. Which test framework is best? The one you will use.
Exactly.
Using one is better than not using one. So if you don't already have one in hand, grab one and start making use of it where you're able to. And the earliest application you're going to find will be in library or potential library modules. Code on forms as little as you possibly can. Keep event handlers short. Factor out business logic from forms into business logic units. Factor out data manipulation into data modules. So if you have a big complicated form and you refactor that, you should end up with 3 modules where you started with 1. And the first one is the form you started with. The second one holds the business logic that you factored out. And the third holds the data manipulation that you have factored out. And once you've done that, then you can start thinking about refactoring what's in those newly created modules. I wouldn't bother until then, because you're not going to accomplish as much. And once you've gathered things together, when you have all of the business logic for a form in a single module, then you're not distracted by the data manipulation that was previously in the middle of it, or by the form behaviors. And similarly for the data manipulation, all of it's easier to look at and easier to work on productively once you've done that basic separation. And when you write the business logic to be used in a separate module or from a separate module, then it's written in a more testable way. You will interact with it through parameters that you pass rather than through common access to field variables and so on. And like any other aspect of the process, you are not going to achieve testability over. There is also, I think I touch it later in the slides, there's also the issue that lots of people like test-driven testing or test-driven design. That's great, but you can't do that because you already have a functional design. You have a successful product. The people who like to get really dogmatic about it and say, no, you have to write tests first, then you stop yourself before you begin. The bad news with unit dependency cycles, they exist because of design errors. Things were put together in a single place that ought to have been separated. The only way you can reduce the unit dependency cycles will be through changing the existing design. You have to separate those things out as they should have been in the first place. Once they're present, they metastasize. Each new module that makes reference to an existing module that suffers from unit dependency cycles will also suffer from unit dependency cycles. And a big problem is when you have a chain, and one of the add-ins I'll talk about later, MMX, can deliver a report to you of the unit dependency cycles. It's not very helpful to human beings because it's an ASCII text file, and when it's 4 megabytes of text, you're going to have a very hard time learning anything from it. But one thing you can learn is that when you see a cycle chain that presents as a CSV string that contains over 100 members, then the challenge is, where does the problem begin? Which of these modules are creating the problem and which of them are only caught up in the chain? That's a huge challenge in dealing with unit dependency cycles. There is not an existing tool that will help you to identify those. Not that I've found anyway, and I have looked high and low. The good news is that they do yield to persistence. You keep hacking away at things and eventually it gets better. And sometimes, as I mentioned already, a small change, moving a single routine, might reduce your count by hundreds. But like all the legacy project work, UDCs don't resolve quickly. Helpful tools. CNPAC is, I consider, is essential to all of this because of one feature. You can run a uses cleaner function from CNPAC that will identify a list of modules which are in your uses clauses and may not need to be there. I say may not because some of the ones that they will suggest don't need to be there do need to be there. But after a bit of practice, you'll recognize that. In particular, they will flag a lot of DevExpress modules as being removable. And the good news is that since those usually are in the interface section, you take them out and you do a file save and Delphi puts them back in again. Believe Delphi, they need to be there. And in spite of that, CNPAC is still very useful in dealing with the uses clauses. GExperts for the grep search in particular is very helpful, and also for the ability that grep search gives you to replace things quickly. An example being, if you've moved a type definition into a module of its own, and now you have 27 modules that won't build because of that, you can do a search on the old module that was referenced, and you'll find quickly the list of modules that were making use of it. Each of those now needs access to the new module in order to build. And after that, each of them should be run through the uses cleaner in CNPAC because some of them won't need the old module anymore. Fix Insight. Unlike the other tools in the list, Fix Insight is a commercial tool and I recommend it highly. It's basically lint for Delphi. It checks an awful lot of things and points at things that should be given attention, things that are not covered by hints and warnings. And the more you use it and the more you act on the suggestions that it offers, the more it's likely to affect the way that you write code going forward, which is a benefit as well. MMX is another essential tool, another free tool, and it's essential because you can use it to analyze the unit dependency cycles. And it will, as I said, it'll give you a possibly very large text file containing information. It also provides a graphical presentation that in a big project I don't find useful, because basically you're looking at a Cartesian chart that is too big to display. However, there are ways to deal with it. I built a tool that I talk about in the book, which parses that file very easily and delivers a data set with the module names where the count was greater than 0, and then delivers only the count itself, which is enough to reduce the noise level hugely and point at the modules that are the most involved, which may give you some of the low-hanging fruit.
Someone pointed out that your list is not alphabetical order.
Yeah.
Because 4G. But also, the question was how well these all play together if you use all of them at once.
I have not encountered any problems having them all present at once. There are both CNPAC and GExperts present an awful lot of stuff.
Yes.
And there's a fair amount of overlap in what those two present. Some of the people I work with have noticed that CNPAC in particular introduced some IDE performance penalties. And the answer to that is fairly straightforward. There's an awful lot of stuff in it that you can just turn off.
Yeah.
If you keep the uses cleaner, which I consider essential, my preference is for the structural highlighting in CNPAC rather than the former Castalia now built into Delphi version, mainly because I've used it for so long. I'm just accustomed to it. There's an awful lot of stuff that you don't need. You don't need their prefix handler for components on a form for changing the prefix name. And there's just a ton of other stuff. You don't need their code formatter and on. And when you turn off these various things that you're probably not going to use, then whatever was going on that introduced the slowdown has been eliminated, and you keep what's left and carry on.
I've used all of those together in the past, and one thing I found is sometimes that the keyboard shortcuts and stuff maybe override each other. But yeah, doing a little bit of customization, turning off things you don't need, they'll work fine together. It just sometimes takes a little bit of effort. But each one adds so much. Oh my goodness. They're such valuable tools.
I was going to try and avoid the discussion of shortcuts because lately Delphi's added some that get in the way of some of the plugins where I want to use their functionality. And dealing with all of that stuff is increasingly troublesome in the Delphi environment. But anyway, the other thing that I do suggest for a project like this, and you won't use it often, and what it gives you will take you a long time to process, but Pascal Analyzer from Paganza is the only tool I'm aware of that will give you suggestions of modules that can be moved from the interface uses clause to the implementation uses clause. And the alternative to that is extremely tedious. So I recommend it for that use, and Pascal Analyzer Lite contains that functionality and is free, whereas Pascal Analyzer is a subscription tool. There is, to borrow from Fred Brooks, no silver bullet. There are difficult tasks. Demoting users' references, which, as I just talked about, is one of them, and only Pascal Analyzer will help you. It'll give you a very big text file, and you can then search through it. They flag these things with text-shaped arrows, to minus signs and a greater than, I think, for the move to the implementation section, or two equal signs and a greater than sign for can be removed altogether. And unfortunately, as with the uses cleaner in CNPAC, they will give you false positives. Both Pascal Analyzer and CNPAC seem to have difficulty recognizing that a class helper module is needed. But that's one of those things you just learn about and say, aha, okay, so when they tell me I can remove it, ignore that and move on. Upgrading, whether you're just talking about trying to clean up and refactor things, or whether you're truly upgrading to a later version of Delphi. Upgrading any non-trivial legacy project will always be iterative. It won't yield to any kind of linear attack. Separation of concerns. A primary example of mixing concerns would be a Delphi form, which contains business logic, data sets, data manipulation, large and confusing routines. And I've already mentioned, but reiterate here, you can separate things out, retaining the UI form, a business logic unit, and the data module. And each of those may then also be making use of routines available from library modules as you promote things into the library. As Fowler says, if you have to spend effort looking at a fragment of code and figuring out what it's doing, then you should extract it into a function and name the function after the what. But equally, if it's really large, you should, as I mentioned in the next point, extract nested routines as a first step. You don't need to see 27 assignments to fields in a data in the middle of your logic. So take that chunk and put it in a callable nested routine. Get it out of your way, give it a good name, and the more you proceed through that kind of behavior, the more that large routine will shrink and become readable at the level of actually telling you what it's there to do. And also, you may uncover in that process that there's the repetition of some blocks of code, and you'll gain some benefit there through making use of the nested routines, possibly modifying them to add some parameters as needed. You may also find routines that you've extracted that seem very familiar and appear in other modules where you saw more of the same. And over time, those should either become part of a library module, or perhaps you're going to create a class that accommodates the behaviors that you're trying not to repeat. Incremental attack, I've touched on. Any large project will yield incremental improvements. Legacy products that can't be unit tested present challenges to improvement. How do you make changes without introducing defects? The main word is be careful. How to reach a unit testable level of code? More of the same. You really have to be careful, and you have to think very clearly about how you can most easily recognize whether you've created a problem. If you proceed through the extraction of nested routines, that's a pretty low risk step by itself. When you start factoring things out, moving those across into a separate module of business logic, that's another opportunity for something to break, probably yields to introducing some parameters that you had overlooked earlier. But redesign and rewrite from square one is massively risky. The opening assumption was you have a commercially successful product, and you want it to stay that way as you proceed through this. There's no management team in the world that is going to commission you to spend an unknown amount of time greater than a year trying to redesign an existing product to introduce a brand new product that may bring with it many problems of its own.
Yeah, there were a couple of questions about this in here, and I've never heard of a rewrite that has come in even close to budgeted time. It's always been a huge disaster.
And there's one in particular that I could remind people of, which was when Borland bought DBase and recognized that they'd bought a train wreck and made the commitment to rewrite it. And the rewrite was successful, but it took so long that they lost the customers.
Yeah, and there's a ton of examples. One of the examples, so I'm a huge fan of Firefox browser. And when Netscape open sourced, they cleaned it up. They're like, you know what we need to do? We need to rewrite this. And it took a long time before that became anything even remotely usable. And there was a lot of articles written about the fallacy of rewriting. And there's a lot of people, especially if you're coming into a existing project, that you're like, I just want to throw this out and write it again. Because we all love writing greenfield code. But it really, if you do any kind of research at all, it very rarely goes even remotely well.
And the reality is that along the way, there are going to be pieces you will find you can redesign and rewrite, but in the spirit of refactoring.
Yes.
It'll be something where you've said, okay, first we move these pieces out into a business logic module. And then as time permits, you start looking at What could I do to clean up this module? And again, now you have the benefit of dealing with something in isolation, where before it was tangled up with other behaviors. A couple of years ago, I took a fairly large and complex form just as an exercise to see on something that big how difficult it was to do this 3-module refactor. Not trying to make improvements or changes in functionality, but trying to preserve the functionality, but isolate business logic and data manipulation from the form. It took me, I don't know, somewhere in the neighborhood of a half day. And I consider that a huge payoff for a small investment. The module was in the neighborhood, I think, of some 8,000 or so lines of code. So to be able to untangle that and gain that degree of isolation with such a small investment, I think is a huge benefit. Anyway, refactoring offers a less risky approach because it's incremental, probably faster than a rewrite from scratch. One of the problems with rewriting is you need a spec. Where's the spec? It's probably the existing code that you're having trouble understanding. If you try to extract a spec from code that you're not sure you understand, that's going to go well, isn't it?
Yeah, you might as well refactor it.
Exactly. You're going to have to go back in order to write the spec. And by the time you've factored it, you don't actually need the spec for a rewrite because you've accomplished the rewrite or the benefits a rewrite could have brought.
And that's the thing. The other thing that happens with rewrites is that so often you think you know the spec, and then you send it out to customers, and they're like, "Well, hold on, you're missing this," and you're like, "Missing what?"
Yeah.
I see that in apps all the time, mobile apps and stuff, where they're like, some new version comes out, and they rewrote this, it's unusable. And you lose so much of that business intelligence. There's so many, all the time that's been spent in fixing bugs and adding features, that's huge. And you lose it all in a rewrite. I'm sorry, sometimes rewrite's fine. I'm sorry, but I get really frustrated with that as a consumer.
And one of the benefits through refactoring, and in particular through working your way through the extraction of nested routines, is you come into a module that Fix Insight has helpfully told you has too many local variables, and it says there's 89 of them. The threshold value, I think, in Fix Insight for an acceptable number of local variables is 8. But as you work your way through it, extracting nested routines, you are almost certain to find that some of that problem goes away by itself because some of those variables are only needed within the scope of one of the nested routines. So you move them there, take them out of the containing routine. And again, it's gaining incremental benefits. So you don't have the great rush of building a new module and testing it all out and deciding this is good and isn't that great. No, it's not like that. But there's a different kind of satisfaction rush that you get from having reduced a large routine that nobody really fully understood to a collection of smaller, very understandable routines and an outer routine that now explains itself. There we go. Lost control of that for a second. So the process outline for the incremental attack: create separate modules for business logic and data, factor out nested routines, collect similar nested routines and replace with methods. But with a footnote that maybe part of this process is going to lead you to create a class to contain some of those things that might perhaps wind up as a class private to one of these modules. Extract private methods from forms and move them into business logic. Extract data sets to the data module. Extract data manipulation to the data module. And at every turn, though I didn't identify it here, take every opportunity you discover to reduce the scope of anything you touch.
There's a couple questions here, actually, might address right now. So Daniel says, is it possible there are too many problems to refactor? I have a 25-year-old project that has an entanglement of UI, data, and logic, use of dead components, an unused feature. My gut says rewrite it. How do you decide?
I guess the first question is, how big a project are we talking about? Is it dozens of modules or thousands of modules? Are we talking about 80,000 lines of code or 3 million lines of code? Those factors are important to reaching a decision. Another factor is are you in a position without reference to the code to sit down and write a solid design specification? Because if not, then I'm going to say refactoring wins on that basis alone. Because the need for a specification, if you're starting over, is huge. And yeah, okay, you can go back and exercise the existing app to check things as you proceed. But if you have to do very much of that without the benefit of a full specification, you're losing time. And on the other hand, if you take the refactoring approach, everything you do is making your life better.
Yep.
It's reducing problems, not creating them.
Yeah. It's something that can be hard to measure, but realistically, if you can go back and look at how many hours you've put into getting the program to the state it is today, the reality is you'll most likely have to reproduce that, because each of those hours, each of those change requests that fix the bug or add a feature, you have to do it. You're going to have to do it again. And if you don't factor that in, if you go back, oh, I still have my original spec. Okay, but you're most likely going to reintroduce all the bugs you had before, or a good chunk of them, and you're going to have to go back and refix them all again. So it is tough. It really is. He says he has a lot of dead components, unused features. I've replaced components before. It's not a lot of fun, but I've had systems where it's like, oh, this component's no longer available. You can make the facade pattern or adapter pattern or whatever it is, and make a different component work like the old component and make the code 90% compatible. So there are techniques you can go in to do that, but yeah, I've been involved in a few rewrites and they've never gone well.
If it's a large project, and let's say the project is 15 years old, then a real consideration that factors into this is what has been the turnover in developers over that time span. Because to the degree that you've lost developers who created the original modules, you've lost knowledge of those modules. And certainly there are people on hand now who have been working on the modules and so on, but their comprehension of the original design motivation is incomplete. And so that's another factor. If you're talking about a fairly large project that was a one-man project, and that same man is about to rewrite it, that does change the considerations. I would still argue for the refactoring.
Yeah.
Because if you're doing it well and with care and making your gains in terms of testability and so on along the way, you'll reach a point, possibly relatively soon, where you're ready to say, okay, this is better and I'm going to ship from this branch. And now the refactoring continues to make improvements in things that are going out to customers and making them smile instead of curse.
Exactly. That's what I was going to say, is that the huge advantage. So we're operating from the basic idea that you have a legacy project that is successful, it's working, it's making you money, or it's being useful. And refactoring, yeah, you're going to have a period of time where you're going to be like, this is a lot of work, I'm not having anything going on, but you're going to get pretty quick to that point and you're like, okay, I can ship this now, I can fix bugs now, I can add new features now, and it's going to get easier to do that as you go along. And so the reality is a rewrite. It's okay. Are we okay not shipping updates for a year or multiple years? Or do we want to or would we rather just have a month or two where we're like, we got to freeze and then we'll have some updates and stuff? Because a rewrite, yeah, if it's any complexity at all, the reality is you're going to have a huge, or you're going to maintain two code bases, right? We're going to fix the legacy framework, legacy application while we're rewriting it. It just seems like a terrible investment. Anyway.
And I might suggest as well that as part of making the decision, that you take a fairly complicated form and do that refactoring to extract a business logic module and a data module and separate the code out across those three modules now, reducing the clutter on the form, and see, first of all, how long did it take? Secondly, you should be able to replace what you started with what you have now created. And you should then be able to test that the same way you tested what was there before. That'll help you to get a measure of confidence about just how big a project is this, because you can then step back and say, well, okay, that was an average complexity form, and there were 300 like that in the system. And so start doing a little multiplication just and add in a fudge factor as well, because you'll be optimistic, as developers always are. But still, you gain some means of getting some kind of an estimate that introduces a level of reality to what your future looks like. And one of the realities is, if it's a complicated product for a specialized customer base, then no matter how confident you are that you're going to do that rewrite in 3 months, I'll bet you'll spend 3 times that on it or more and still have customers complaining about defects.
Yep. So Daniel just said that his application, 25 years old, 17 developers of varying skills, 2 remaining developers with one with a couple of years from retirement, and about 700,000 lines of code. It's easy to say, oh, 700,000 lines of code, that's a developer can write X number of lines of code, so that's how long it's going to take. That's not an accurate measurement, because each of those lines of code has been poured over so many times and tweaked so many times that there's so much more that's gone into that than just the initial write of 700,000 lines of code.
And I'll offer a sidebar on that. If you've got a product that's evolved over 25 years and you've had 17 developers involved along the way, somewhere in the middle of that collection of developers was somebody who wrote clever code.
Yeah.
And when I use that phrase, I am not being complimentary.
Yep.
Clever code is something that puts a smile on his face, but is enormously annoying to maintain because nobody understands it.
Yep.
And that comes back to, I think it was another one from Fowler, that any developer can write code a computer can understand. A good developer writes code a developer can understand. Something that gets lost along the way. We're not here to communicate with a compiler.
Yeah, you're here to communicate with the developer that's maintaining it. Absolutely. That's so true.
And another piece of advice, I think, from Coding Horror is to code as though the person who comes after you is a psychopath and knows where you live.
Exactly. And frequently that psychopath is me. I see my code from not that long ago. I'm like, who wrote this?
So on the subject of refactoring, Fowler again, if you're afraid to change something, it's clearly poorly designed.
Yes.
And that increases the pressure to redesign it, or in fact, to refactor it, because you have to refactor it in place. That is, maintaining its strange operations that you don't yet understand, but chipping away at it a chunk at a time until you reach the point where you can finally say, oh, okay, now I understand what it's doing. Why on earth they did it that way, I don't know, but now I understand it, so I can fix it.
Someone asked a question about Clever, and I want to add something here to this. I've worked a number of really large projects that have been around a long time, and I talked to a lot of developers in the same boat. And some of them do a good job of upgrading newer versions of Delphi fairly frequently. And there's been pieces of code that pretty quickly you come onto the team and they're like, yeah, hopefully you don't have to fix anything in this area here because the guy that wrote it was too clever. And it stayed there. And it's like, don't touch it, don't touch it. But at some point, someone's like, you know what? We got some time. I'm going to fix it. And he went in and refactored it and made it usable. And they're able to get rid of that morass of clever code. But the reality is during this time, this program was still shipping, still getting new clients, still making money for the company. And if we had decided to rewrite the whole thing from scratch and not just ending it and updating it as needed, and then eventually replacing these unmaintainable portions, we wouldn't have had that. And yeah.
Yeah, and a number of years ago, I worked on a large project, D6 project, that had a particular module in it I had to work on a number of times that contained tabbed pages, 13 tabbed pages. And some of those tabbed pages contained tabbed pages. And the total count of components in this thing was about 1,300. And when it would present, this is from Delphi 6 and in the context of Windows XP, it took 30 seconds for that form to appear on the screen. But along the way, it would draw the border of the form empty. And then downward and to the right of that, it would draw a second border of the form. And then after some further delay, it would finally draw in a third location the form itself with border, and the other two borders would disappear. Now, the separation of those borders is explained by the fact that in XP that was Luna, and Luna was applied. It wasn't actually a part of the form. That border was a separate piece. So that was part of what was going on. But one of the complications was that this form was being used in two applications. And in one case, it was a normal form. And in the other, it was set at runtime to be a child form, which you're not supposed to do. Delphi Help clearly says, don't do that. Do not change the form style at runtime. And there are ways to make it less painful, but it's still not something you ought to do. A better answer would be to create two forms and fill them with a shared frame containing the rest of it. But anyway, long digression there. So like it or not, refactoring is going to be at the core of anything you do on a legacy project, because there's stuff there that you can't maintain. There's stuff there that nobody understands. The only way you're going to fix it is to refactor it. And as time goes on, and the more you do that, the better your skills at refactoring things are going to get. The more you're going to recognize patterns that are local to your particular product. And refactoring is not a step, but an endless process. In almost all cases, Fowler says, I'm opposed to setting aside time for refactoring. In my view, refactoring is not an activity you set aside time to do. It's something you do all the time in little bursts.
Yep. A lot of stuff on code debt, which is a really interesting topic, which is the idea of that if you're not doing those little bursts of refactoring, if you're not doing the things to maintain your code, and there are some times when you're like, I got to fix this right now, I got to add this right now, I don't have time to do anything but a really kludgy hack. That's fine, but you got to realize that you've taken on code debt and you're paying interest on that code debt the longer it sits in your system without being addressed. And you're going to have to invest time later to fix it.
Code debt or technical debt, whichever term you use for it, is that it's no more pleasant than paying off credit card debt.
Yep.
But it's just as essential.
And it will foreclose on you as well at some point if you do not pay it off.
Now, there's another thing that I'll point out in this screen, besides the issue of the code itself, is the use of an exception handler that doesn't actually handle the exception, it just swallows it. And one of the difficulties, I think, with old code is that a new release comes out, you start using it, and don't fully explore what's appeared in the libraries, the Delphi libraries. I don't know at what version try string to int and try string to whatever appeared, but they were very important because they won't throw exceptions. And they will tell you, if you need to know, whether or not the conversion was successful. So here's this case where somebody who didn't understand that wrapped it in a try except with no further explanation, when they could have replaced those 4 lines with a single line with the same result, but without an exception being thrown at any point. There's a lot of stuff that gets done. I've seen things where people put in an if clause, if condition equal true. Really? Or if condition equal false. So they don't understand what a Boolean is, apparently. They don't understand that they could use not for a false case. And even in cases where the stuff is done more cleanly, there's also something that's often overlooked about Boolean logic, which is that almost everybody finds it easier to understand positive logic than negative logic. And converting it, even if, and sometimes because you may decide to first create 2 or 3 local variables that can create partial products so that you can then wrap those in a single easily comprehensible if clause, may be a huge gain in terms of your understanding of what's going on. Anyway, so the point here was that those 2 snippets of code are equivalent, but one contains a potential problem. And a further problem with the empty except clause is that sometimes they get pressed into service simply because whoever was doing the work at the time recognized that an exception was thrown in the area and they don't know why. They don't know what the cause of the exception was. And rather than find it, They just said, no, I don't have the time. I have to get this shippable. And so they wrapped it that way. That's a ticking time bomb. It'll bite you sooner or later. It'll upset a customer in the field. And it offers no clue in passing as to what actually happened. The short answer is don't do that. Always try to eliminate the root cause of an exception. And also, as it ought to be fairly obvious, handling an exception should happen as near as possible to the cause of the exception, not 3 or 4 layers up in hierarchy of calls. Okay, as developers, we all have different points of focus. We all have our pet peeves and whatnot, things that make us grit our teeth. And sometimes we be focused on our particular area. And that's one reason that we may not explore as deeply as possible into what has changed along the way. One of the examples that I would point at is date time variables. I can't tell you at what version it happened, but Delphi provided support for ISO 8601. And there's a whole lot of older code that may have been written to try to deal with the particular cases along the way. But that stuff generally can be replaced with calls to a library function at this point. And to the degree that you're able to use those libraries, you reduce the burden of your own testing. So simplify your life, study new releases, especially libraries. They can simplify your code. Your own libraries.
There's a few comments about this as well. I'll let you finish that next section and then we'll talk about this.
Your own libraries can be improved by study of the Delphi libraries, because you're going to find opportunities to eliminate chunks of code that you've written before. Or you may simply say, oh, gee, that's an interesting way to do that. I hadn't thought of it, and it's cleaner than what I had in mind. Again, just hammering the same point, study libraries.
Yeah, actually, that's one of the things I love about Delphi is that it originally shipped with all the library code and stuff and made it. And so it fostered that ability to study that and learn about it and stuff. But there's a few questions here about using third-party libraries and stuff as well.
Coherent component use. When we first used Delphi, many of us were excited to get new components and overeager to use them. So in a legacy project, you may find that you have components from a dozen or more different vendors. And some of those you might want to replace because they lead to an inconsistent appearance in the user interface. Others you might want to replace to make the code simpler overall, in that they don't all support the same properties, they don't all support the same event handlers and so on. And if nothing else, over the long haul, the more of those component packages that you can get rid of, the more licenses you could stop renewing every year. Consolidating components will help make your code more consistent. It makes the appearance more consistent, reduces license fees.
Some people are talking about that, we don't use any third-party components or something like that. I would say using third-party components is a really good investment, and honestly, license fees is good. But your comments here about not using a lot of different libraries is really important. Each one of those you do is an investment, but it's got benefits, and if you got to look at it and decide if it's worth it. Now, if you're buying component vendor X's suite of components, I'm sure they're all fabulous, but if you're only using one drop-down box from it, then that might not be a good investment. But if you are buying a suite of components and using a lot of those, that's a good investment. There's not really any hard, fast rules. It really depends on your application. But I think third-party components is a really good investment, whether they be open source or commercial. If they are commercial, you are essentially, can think of it like you're outsourcing that development, that maintenance of that component, and fix the bug fixes and new features, but you don't have to pay the full amount of that. You're splitting it among other developers. Now, again, if you're only using one out of the full suite, that might not be cost effective, but it is not like going back to there's no silver bullet. It is a balance, and you don't want to have too many, but if you're not using any third-party components, you're doing yourself a disservice, in my opinion.
Yeah, you're working too hard. But there are also components out there that may be unique in functionality to a single vendor.
Yep.
One example that comes to mind is a button where the caption can be link. Not a lot of people out there offering that. And so if you made use of it along the way and you've got a customer base that has been accustomed to using that for the last 10 years, deciding to change how that works now may cause some dissatisfaction out there amongst the users. Then, of course, that leads off into another potential rabbit hole to subject analytics, which you may or may not be able to use. But if you don't have hard data about what parts of your product are most useful or most used by your customers, then deciding on particular changes is risky as well.
Yes, so true.
Okay, so using tools in Delphi. Already mentioned these tools, CMPAC, Fix Insight, GExperts, MMX. The links are out there, but they're here, but you can also find them with a simple search. These have all been around for a long time, all widely used and well respected. Custom tools. You can build your own. In a legacy environment, you will find you probably need to build some of your own because none of the tools you found available, whether open source or commercial, provide the operations that you need. A lot of times the operations you need are relatively simple. Not always. Some of them may lead you into needing to actually parse the code, and that's a whole other level of challenge. And the tools is also likely to be a learning experience, which may be another reason that you want to do it. Reasons not to do it are the time burden. The operations of interest are too complex for your experience. You can't estimate the risk or development time. And there's another one that I didn't mention, which is maintaining it. Mm-hmm. People say, oh, I can write that. Yep. You're going to maintain it? Somebody says, hey, it's got a problem. You're going to fix it? And that is a real concern. It's like lots of clients that I experienced in my consulting work. I had the experience of some IT guy who said, hey, I can write an app for that. And then he did and left the company. And now they have this problem. Nobody else knows how it was written or what it really is supposed to do. There's no specification that was ever created, and it has a problem. Good luck with that. And whatever estimate you offer them to replace it with something else that you can and will maintain, they probably won't like the price.
Yeah.
So the reality is that I can't begin to present all of the stuff that I'd like to in the course of this webinar. I sat down to write the book without an expectation of how long it would take. And 2.5 years later, I was ready to publish it. So there is an awful lot there. There's about 480 pages in the book. And while I do harp repeatedly on some topics that are really important, the truth is that there's a lot there. You don't have to read it cover to cover. There may be chapters in there that you want to postpone for 6 months because you don't see any way to make use of them, and that's fine. I do refer back to things that came before, but to a great extent, I'm not presenting code you can use in a building block fashion. I'm looking at issues, strategies, how to be successful in trying to rework or remake your product without the potential disaster of starting from scratch. Paperback is available on Amazon. The PDF is available on my own website. And from now until the end of next week, there is a discount on the PDF. And there's a coupon code that you have to type in. It's pretty straightforward and appears on the last slide in this presentation. If you haven't read Martin Fowler's book, Refactoring and Improving the Design of Distant Code, do it. The examples are all Java, but the value of the book is in the mindset and the processes he follows. Also useful, Michael Feather's Working Effectively with Legacy Code. Again, it's not Delphi, and so when he gets into the details of the specific coding changes he's making, it's not going to be so helpful. But again, it's more about the process and about how to look at things. And there it is, last page with the webinar discount, and that's what I have.
Awesome. So I've been trying to answer questions as we went along. There's a few of my saved here for the end, and we're not a lot of time left, but you may have mentioned this, I don't recall. Ross asked if there are any tools for identifying unit dependency cycle issues within your project.
Yes, Max will do an analysis of the project, and it will deliver a visual presentation with a number of pages, and you will have a list of all of the modules that it has processed. You select one of those, and then there's a page that identifies the modules used by that module, and another page identifies the modules that use that module. And the next page is where it starts to get hairy in large project because it tries to present in Cartesian presentation all of those relationships, which was probably fun to write, but I don't find it particularly helpful, because when you start having to scroll both horizontally and vertically in order to take it all in, then you're not going to be able to take it all in. What is better is you can save the report to a file, which is plain text, and at the start of each module that it's analyzed, it'll put in a line of text that says module such and such with a count of the number of unit dependency cycles that it found. What follows that is a collection of lines containing CSV lists of what was in each of those cycles, and that can be horrible to try and look at. If it said it was in 150 cycles and it turns out that 80% of those cycles contain 100 or more module references each, then what do you do with that? The answer is close the file. I have a tool that I put together that'll let you open 2 of those reports. And so you can then see, for the reference report, you can see a presentation showing the count of cycles in that module or in that report and the modules in which they appeared. And on the second module, what you end up with is another column of data added to it for those modules, which shows the number of cycles in that second report. When you're really focused on trying to reduce unit dependency cycles, the fact that tool will give you a total for 2 different revision points, as well as a quick sense of what are the worst modules in terms of involvement in this stuff, is helpful. And even though it's depressing to see up at the top that you've got over 20,000 unit dependency cycles, it gets a lot nicer when a couple of weeks later it says now you're below 19,000.
There's a question here from Stephen about Unicode. So moving from pre-Unicode Delphi 5 to current Unicode versions. I think that's something you addressed in the book, right?
Yes, it is. And the short summary that I present in the book is, first of all, any parameters, it's really parameters where this becomes an issue for the most part. Any parameter should be using the ordinary default string type, unless there's a compelling reason to do otherwise. A compelling reason, for example, would be because you're having to interface a third-party module, and so you have to put things in the form that they want to process. But within your project, you should be using default types. Argument 1, that those default types are probably the most efficient types handled in Delphi because they get the most attention from the development team. Argument 2, because it reduces the complexity of what you're trying to deal with. And also, if you're migrating to a recent version of Delphi, you're going to find that even if you came out of the old compiler with no hints and warnings, suddenly you have a bunch of hints and warnings because it's going to report implicit casts that have been done, because over time Delphi has become much more critical of typing and wants you to be more critical of typing, and you should be, because it's an easy way to reduce the risk of defects. So yeah, there are reasons to not use the encode string, but there are more reasons to use it. The actual conversion, how difficult conversion is, the answer is it depends. And there are good documents out there that you can find. I mentioned them in the book. There's one Marco Cantu wrote some years ago, and another one that, oh, come on, brain, Nick Hodges wrote.
Yep.
Those 2 are independent of one another. There are good reasons to read both of them and understand them, and they will help. Delphi does a lot to help deal with the transition with least possible pain. When you come into dealing with streaming, that help may not be helpful. I've seen a case in particular where Delphi tried to help by providing conversion. That, combined with a blob field in a data set that had, in an older compiler, been flagged as text, was a bad thing. What needed to be done was to convert to a binary blob, which didn't change the content at all. But what it did was tell Delphi, don't mess with it because you don't know what this is. And the problem when Delphi tried to fix it was that they were taking a bunch of stuff that needed to be handled as 8-bit characters and turning it into Unicode characters, which broke a whole lot of stuff.
There's a few questions here about, I've got a lot of X I need to change to Y, as well as I'm using BDE, I want to change to something more modern. Is that something you get into the book at all about, like how to migrate away from BDE, or any suggestions you have
No,
for that?
no, I really don't talk about BDE. There's probably 80 million different ways to approach that at this point, and I think it's been written about all over the place. Certainly, I want to say, and maybe I'm not remembering correctly, but I want to say that Kerry Jensen has probably dealt with it
Yeah.
in his client datasets book, and I think even in his FireDAC book. And certainly the advice he offers is good. So I would start with that. And also, one of the questions about how to deal with it is, well, okay, what's your context? Is it a tool that has only a single user, in which case you could use, for example, embedded Firebird? Or do you need a multi-user database like Interbase? That's so fundamental to the whole question of how do I move away from BDE that it has to be a part of the original considerations.
Yeah, absolutely. I will say, so Kerry Jensen, and if you haven't read some of Kerry Jensen's stuff, he's amazing. But when I first started in Embarcadero was actually right when we acquired FireDAC, and it was just changed from FireDAC, or it was like a separate download. It was just right at the very beginning. And I had gone to Kerry and asked him if he had written anything about it, or if he wanted to write anything about it. I was like, I really need to dive into it and understand it better and stuff. And then a couple of years later, he came out and said that he was doing a consulting for somebody, and they were using an old version of, I can't remember if they were using the predecessor to FireDAC or if they were using an original FireDAC, and they had some issues. And he's like, try upgrading to the new version of FireDAC. And they did. And it fixed like so many issues and made it so much better. And since then, he's written his book on FireDAC and talks a lot about FireDAC and become a big fan about it. But he wanted to do the research on it and such. I did put a comment here that there is a Refine that we provide, and then there's also Delphi Parser by Oren, who's on as well. I saw him pop up in the questions, that are specific tools for migrating from BDE to FireDAC. There are other third-party tools out there. There's other third-party frameworks out there. Honestly, I don't care what framework you use. A lot of people feel like I'm the FireDAC salesperson. I'm not. So use whatever you want to use. But FireDAC is a really good framework, and it does get the job done. And it's included in Delphi. There's a question here about code formatter, using the Delphi, the code formatter that was introduced in newer versions of Delphi to reformat code written in older systems as a step in the refactoring. Do you have any comments on that?
Yeah, the problem with refactoring is if you're part of a team, unless the boss says, this is the format we're using, you're going to run afoul of people's preferences. And when that comes into play with source code control, it gets very unpleasant when it's time to do a merge. That's a first issue you have to address. There are also different aspects to code formatting. There's a code formatter built into Delphi. There's a code formatter that is part of GExperts, which is similar but different. And then there is some degree of formatting built into MMX, and in particular on new code, I will use MMX to sort a class, because over time I find it comfortable and convenient to have everything in alphabetical order in the class. But there are people who prefer to try to maintain functional grouping. And of course, that only works until the size of the class reaches some threshold and it becomes too much, or this method is involved in too many other things, so you can't really group it that way anymore. On the other hand, that may be an indication that you ought to be factoring out some smaller classes that can be members of the larger class. But formatting is an issue. If there's no agreement and there's nobody willing to say by mandate that, nope, these are the option settings you will use in the formatter, then it may not be practical to apply it.
So we talked about this. I don't know if there's anything you want to add, but it says we often struggle with deciding whether or not to even attempt to migrate our old programs to newer versions. Do you have any advice on trade-offs to be made when deciding whether to continue to maintain an older app or to go through the pain of upgrading, or even migrating away from Delphi?
Migrating away from Delphi is the same question as what if I rewrite, because that's what you're doing. So I'll turn away from that and just deal with that question, the question of whether to rewrite. You need to have a solid specification. To the degree that you don't, and you try to rewrite using the old code as the design spec, you're kidding yourself if you think you're saving any time. It's not happening. You would be better served by refactoring what you have. But all of that is modified by consideration of how many modules are involved in the product and how many lines of code total in the product. If it's relatively small, then a rewrite may be perfectly fine. And I'm sure there probably are small applications in the world. I haven't had occasion to work on any that made money. That doesn't mean there can't be any. It just means they're not in my experience. Typically, the things I've worked on have been larger, and I can't think of one off the top of my head where I would have suggested rewriting from square one.
Yeah. And the reality is that refactoring often does involve a lot of small rewrites. And eventually, it's the ship of Theseus, right? You can eventually replace the entire thing. But the advantage of coming at it from a refactoring, maintaining point of view is that you continue to ship updates and fixes to your customers, whether they be internal customers or external customers. You're making money, they're getting value from it while you're doing this rewrite. Whereas if you're like, we're just going to start over from square one, then you're not shipping anything, or you're maintaining two code bases.
And if you say, okay, I've really thought about this and we can rewrite this and fully test it in 6 months. And if you're off 2 to 1, and it takes a year, then you have a bunch of customers that somebody told along the way, yeah, it'll be out by May. And instead it's going to be out in November. And so some percentage of those people are now very unhappy. And moreover, they probably haven't seen the updates and bug fixes along the way because you were busy rewriting. Unless you have very deep pockets and can bring on a second crew for the rewrite, that's a very real consideration. How much defect work are you having to deal with on a regular basis? Because unless you increase the size of the programmer pool, which introduces more problems along the way. See Frederick Brooks on that. Unless you can increase the programmer pool, you are going to reduce the productivity on tackling existing defects. There's no free lunch.
Yep, that's true.
Frederick Brooks' point for that, for those who aren't aware of the man, was a simple comment he made that adding developers to a late project makes it later.
Yep.
And there's no way around that. There's no way around it because there's a learning curve and there's a communication burden.
Yeah, you're better off bring them on early. There's nothing wrong with adding developers. It's a great thing. But bring them on early and don't expect them to just magically, if something's going to take 9 months to make a baby, adding more women to the pool late in the 6th month doesn't make them happen quicker. So does your book discuss working with multi-threaded applications at all?
Multi-platform? No.
Multi-threaded, multiple threads? I know Dahlia has some books on multi-threading.
No, I specifically didn't dive into threading because one, I had a huge amount of stuff already committed, and two, I proofread Dahlia's stuff on threading. The right answer is get her book.
Yeah. Honestly, I'm real excited to see your book out, but there have been so many good Delphi books coming out lately. I'm really pleased. Dahlia's got 3 books that everybody I've recommended it to has come back and be like, oh my goodness, I've been doing this wrong for so long.
And just to tease the whole proposition of the book a little bit, I have been a proofreader for Dahlia on all 3 of those, and she has proofread mine.
Great.
So I highly recommend her book on threading. There's also, I'm trying to think, do I even want to try to pronounce the man's name?
Oh, Primoz?
Yeah, exactly.
Yeah.
Maybe Gabrielchik, I don't know. But
yeah, I think that's right.
He's written very effectively as well about performance issues and threading.
Yeah, that's another really good book. Thank you. I had spaced that one.
Although his is more in the direction of leading you into using his particular threading framework, I think.
Yeah, so some of it is, but a lot of it actually is very universal and works with whatever. But he does show some examples from that, which is great. It's a nice framework and it's free. But yeah.
There's a lot in the book that I haven't touched on at all, using the solid principles. And I have small chapters on each of a number of the various tools that are available, as well as on the tools that I built along the way. And there is code available on GitHub for the ones that I published with that. I will say I'm working towards another book and it'll be more focused on tools, but that's all I'm going to say because I don't have the tiniest clue how far away I might be from having something I'm ready to publish.
Yep, it's that rewrite estimation. All right, thank you so much, Bill. I really appreciate this. I found this really interesting. There was a lot of great comments here from people saying that it was fascinating, but they had to jump off. There will be a replay available on YouTube. And yeah, Fantastic. Thank you. I recommend you go check out Bill's book. I haven't read the whole thing, but the parts I have read do look really good. And honestly, I really respect Dahlia as well. And if she's proofread it, that's a huge other recommendation of my book.
Well, thank you.
Thank you.
Thanks everybody for attending.
Yeah. Good luck, everybody, and take care and good work. I'm glad that you're here because that means you have a legacy project that is working for you, and good luck maintaining it and moving it forward. All right. Bye.